Good morning, student. In our last class, we complete up to question number 14 as noted from the exercise 6.5 chapter application of derivatives. So here we have to continue this exercise. So today we discuss another very interesting question. Question is question number 15. As you see here, the question is given here. The question given like in this way. Find two positive numbers x and y such that their sum is 35 and the product is x square y to the power 5 is a maxima. So the procedure is same whatever we have done in question number 12, question number 13, 14, the same process we have to apply here. Again, the sum is given how much? 35 and the product is maximum at when? X square y to the power 5 as noted. So that's why if you consider the numbers first. So here if we consider the number, let one number be. So here if you consider, let one number be x. Clear? The other one, therefore y equals to how much? Therefore the another one. So because here another one we write here 35 minus x. Why? You know what is the reason? Because already given this one, the sum of these two is how much? 35. You see here the sum is given 35, so that's why if we consider one number is x, then obviously the another one is how much? 35 minus x. All of you know this one. So now here if we write the product, let the function, if we consider fx equal to, this one is the product is given x to the power y 5. This one is given to us as noted. Fx equal to x to the power x square into y to the power 5 given. So now in this case what you have to write? This one we write fx equals to x square, and in place of y what we can write? We can write 35 minus x. So that's why here we have to write this one is 35 minus of x to the power 5. Is it clear? Okay. Now after that we get the function. Now our process is same. What you have to do? We have to find out the critical point. And for that, first of all, what you have to do? We have to differentiate this one with respect to x. So therefore if you write, if you differentiate this one, f dash of x. So f dash of x equal to, if we keep x square, then we have to differentiate this one 35 minus x to the power 5. So it is of the form x to the power 5. If x to the power 5, then we write 5x to the power 4. So that's why here first of all we write 5x. X means here 35 minus x to the power 4. But this one is not x, so that's why we have to differentiate this result. ddx of 35 constant term 0 and ddx of x minus 1. So that's why here we write this one is minus 1. Since we applying here u into v formula, so u ddx of v again plus v. V means this one we have to write 35 minus x to the power 5 as noted, and v into ddx of u x square. When we differentiate x square, then what we get here? Obviously we get here twice x. Understood? U into ddx of v plus v into ddx of u. Is it clear? Okay. Now from these two, at first if you see what is common, so if you see here first term is x, here x square is there, here twice x is there. So from we can take x common from here. So first of all we take x common. Clear? And then secondly you see here 35 minus x to the power 4 and here 35 minus x to the power 5. So what we take common here? 35 minus x to the power 4. So that's why here we write this one is 35 minus x to the power 4 we can take common. So if we take these two common, then what will remain here? So from the first part x common, so simply here x remain and with this 5 remain. So that's why here, and including minus 1. So that means here remain minus 5x, and plus in the second part here you see already x taken common, so 2 remain, and with this 35 minus x to the power 4, that means here remain 2 into 35 minus of x. Is it clear? And now this one, if you see this one we write x into 35 minus x to the power 4, and if we calculate this one, how much we get here? Minus 5x minus 2x minus 7x, we get 2 into 35, that means 70. So this one we get here 70 minus 7x. Any more is common here? Yes. From here, if you see 7 is common. So if you take 7 common, then here remains 7x. This one we get 35 minus x to the power 4. And here when we take 7 common, then this one remains 10 minus of x. Now this one is the result of f dash of x. Is it clear? So here f dash of x result, we get this one. So after getting the f dash of x result, now what you have to do, we have to find out the critical point, isn't it? So in case of critical point, we have to write now here, now f dash of x. Now f dash of x equals to 0, we write. So f dash of x means this result we have to write. So that means this one we write 7x, that means this one is 35 minus x to the power 4, and the last one is 10 minus of x equals to 0. Is it clear? F dash of x result is this one, 7x, 35 minus x to the power 4, 10 minus x equals to 0. Okay, now this one, from here, easily we can compare, no need to write, because their multiplication is equal to 0, so that's why we write here either 7x equal to 0 or 35 minus x to the power 4 equals to 0 or 10 minus x equals to 0. And from here we get x equals to 0, here we get x equals to 35, and here we get x equals to 10. Is it clear? I hope all of you understood this tree. Up to this, all of you understood this one. So now here one thing you see here, x equal to 0 and x equal to 35. Since if you see the sum is how much? X plus y. If you see here, the sum is x plus y equals to 35. This one is the given condition given, isn't it? So x equals to, when x equals to 0, y equals to how much we get? 35. Or when, in this case, when x equals to 0, y equal to 35. And when x equal to 35. When x equal to 35, if we put here 35 cancel, then y equals to 0. Since the product, if you see the product is given x square y to the power 5 is maximum. So if their product is maximum, that means neither x nor y equals to 0. Yet x by y 0 hobo nore. If any one of this one 0, then the whole result is what? Ultimately 0. Isn't it? So here x equal to 0 is not possible, as well as y is equals to 0 also not possible. So that means if we write x equal to 0, directly it is 0, not possible. And if we put x equal to 35 here, 35 cancel, then y equal to 0. Then if we put y equal to 0, then it is also not possible. That means from here easily we can say the value of x equal to 0 and the value of x equal to 35, these two values are not possible. Is it clear? So only the possibility is which one? So only the possibility is here x equal to 10. That means here we consider only one critical point, and the critical point is x equal to 10. All of you understood why these two are not possible here? Clear? Okay. Now after getting the critical point x equal to 10, the next step is what? We have to verify at x equal to 10 we get maximum or minimum, isn't it? For that what you have to do? We have to differentiate the function again. So if you differentiate the function again here, f dash of x equal to, the result is this one, isn't it? So we have to differentiate this result again. Now here we have to apply here ddx of u into v into w. Three functions are when we differentiate. You all of you know the formula, ddx of u into v into w. So this formula we have to apply. So how can we differentiate this one? When we have to apply ddx of u into v into w, so first we have to differentiate this one and we keep this two same, as well as second time we keep this one same and third one same, we have to differentiate the second one, and finally plus we keep this two and differentiate the third one. This one is the process, ddx of u into v into w. So when we have to differentiate again, so again we write here f double dash of x. So f double dash of x equal to, if we differentiate this one, first one, you see ddx of 7x, x 7 constant term, so simply here remains 7, and then we have to write the other two result. So that means 35 minus x to the power 4 into this one we write here 10 minus of x plus. So second part is what you have to write here. If we keep this 7x, we have to differentiate the second part. So that means here 7x. Now here when we have to differentiate this one, here we write 4 into 30 minus of x whole cube. 30 minus of x whole cube, and again we have to differentiate this one, so that means here we get minus of 1, isn't it? 4 into 35 minus x whole cube into minus 1, and then the third one remains same, so that means 10 minus of x plus the third one. In the last case we keep this to same, so that's why here we write 7x, and this one we write here 35 minus x to the power 4, and if you differentiate this one, ddx of 10 0, ddx of x minus 1, so that's why here we get this one is minus 1. So now after this one, now in this case, if you see from all these three results, ddx of u into v into w method we apply, and from here what is common? First of all, you see here 7 is common, so we write this one is 7 common, and in the second part you see what common? 30 minus x whole cube common, so that's why here we write 30 minus of x whole cube, and now here when we take, then here 10 minus x, 10 minus x, but here 10 minus x is not there, so that's why no need to take here. So after that, if you see here 7 common, then 35 minus x whole cube common, so what will remain here? 35 minus of x into this one is remain 10 minus of x, the first part. Is it clear? Plus now the second part, in the second case you see here 7 and then 30 minus x whole cube remain, so common, so what will remain here? 4x, isn't it? And with this minus, so that's why here minus 4x into 10 minus x, so that's why here we have to write this one is minus 4x, and this one we have to write here 10 minus of x, isn't it? And finally the last one is, you see here 7 common, this one we take common, so here what will remain here? Minus of x, 35 minus x, so that's why here for last one we write minus of x, this one we have to write 35 minus of x. So now after taking common we get this result, and finally from here if we calculate this one, then we get this type of result. This one is 7, this one we write here 30 minus of x whole cube, and now if we calculate the last part, and if we calculate the last part, and then here we get here 6x square minus 120x, so here we get this one is 6x square minus 120x plus of 350, this result we get here. Is it clear? And if we take common, so 7 30 minus x whole cube, and then here we get 6x square minus, if we calculate this last part, then we get this one 6x square minus 120x plus 350. So this one is the differentiation part. After differentiating, now what you have to do? We have to verify the critical point. The critical point is this one, and this critical point here we have to put, and we have to verify whether the function is maximum or minimum. Is it clear? Okay. So now here if you put x equal to 10, so when x equal to 10, if you put the critical point x equal to 10, we have to verify f double s of 10. So f double s of 10, here we have to put, in place of x we have to put 10, so that means this one we write here 7, this one is not 30, this one is how much? 35. So 35, this one is also 35 here. So now here what you have to do? 7, this one you have to write 35 minus of x, x means what? Here we have to put 10, so 35 minus x whole cube, and then this one 6 into 10 square minus 120 into 10 plus this one is 350, so this one we write 350. So now if you see here, if we calculate, no doubt this one is a positive part, is not it? So 600 minus 1200 plus 350, ultimately if we calculate this one, then here we get this one is a positive part, this one is here, if we calculate, then here we get a negative result. So negative positive, ultimately we get here negative. Negative means less than 0, less than 0 means we write here maximum. So that means it is verified here. We verified here at x equal to 10, what we get? We get maximum value, is not it? So from here easily we can verify this one. So hence fx has maximum value at x equal to 10. So if it is verified, then we have to find out the number. Since the sum is what? X plus y equals to 35. So if x equal to 10, so if x equal to 10, if we put here, then obviously y equals to how much? 25. So y equal to 25. So the numbers are here what? 10 and 25. Is it clear? So this to our required answer. I hope all of you understood this question. So in our next class, we have to continue this exercise. Is it clear? Okay, thank you.